Okay, I'd like to talk about expanding brackets. This is something that you'll do a lot of in when we're working with algebra. To do brackets, let's start nice and simply. Let's start with only having a term outside of a pair of brackets, and we're going to use the distributive law to be able to work out what's going on. Now we can visualize how this is working by imagining that what our expression here is actually the sides of a rectangle. Here, let me show you what I mean. Here I have a rectangle. It has a length of b plus c, which is what's in my brackets, and here. And it has also got a side length of a, which is the bit that's outside of the brackets. Now, because it's like two rectangles, I can work out the area of each of those sections and then add them together. And I'm going to end up with a solution for my expansion of AB plus AC. So using our distributive law, we can actually work out expansions pretty simply. Let's have a look at what I was actually doing without having to draw that then. So if you have a look, what I really did is I multiplied what was on the outside by each term inside the brackets. So I'll say it again. Everything on the outside gets multiplied by what is on the inside of the brackets. So my A here, it gets multiplied by the B. The A then also gets multiplied by the C. And those two multiplications are still added together because there's a plus on the inside. If it had been a takeaway, a subtraction operator, then it would be a subtraction operator right there. Now, once we are at this point, if we can simplify by adding like terms or subtracting like terms, then we can do that. Let's have a look at another example. I'll actually work us through. So, here we've got 5x outside of 6y take 6z in brackets. Now, by the way, I often will put a little cross on a z because sometimes when I get a bit excited, my 2's look like z's, and I don't want to confuse you. So that's how you'll know it's always a z. Okay, so let's have a look. Well, we know that everything on the inside is multiplied by what's on the outside. So what's on the outside? A 5x. So if I could visualize what this next line will be, it'll be this 5x multiplied by my first term, and then it'll be this 5x multiplied by my second term. Now, when I go to my next line, which I've written out, you'll see something interesting. And it sort of kind of goes against what I was saying before. Remember when I said if there was a minus in here, there'd be a minus down here? Well, how come there isn't? Well, the other important thing to remember is that the operator sticks with the term. So this minus 7x, well, it still exists over here. Okay? So that's why there's a plus here. So I multiply these things out. 5x times 6y plus 5x multiplied by negative 7x. So when I do that, I'm going to end up with 30xy from this part over here plus negative 35xz. Now, because we've got a plus and negative, the reality is we can just get rid of that plus sign and it will be 30xy minus 35xz. Alright, well let's try a trickier example. What if you've got two sets of these brackets and you want to expand them out? Alright, well let's have a scenario. Here we've got two sets of brackets. I'm not going to read through it all. You can read just fine, I'm sure. But the process doesn't change. Even though it seems like it's a more complicated question and it's a little more involved, it doesn't actually change the process. Everything on the outside is multiplied by what is on the inside. And we'll do the same thing for this second lot. So everything on the outside gets multiplied by what's on the inside. Okay, so when we do that, we will distribute it out and we will find that the 7 here gets multiplied just by the x. And I've shortcutted so that we didn't go through the long process of where the signs go up here. So the 7y is multiplied by a negative 2y to get negative 14y squared. Okay, don't forget, if there's a y on the outside and a y here, it'll be squared or cubed or whatever it is. Then we have plus, and then I've also used the same distributive law to multiply out this other bracket. I then look for like terms, and there are actually like terms here. I've got a negative 14y squared and a positive 5y squared. So I can do that. Negative 14y squared plus 5y squared, I'm going to end up with negative 9y squared. And that would be the end of it.